Our first question is, we are given a box resting on a horizontal surface. The box is 50 kilograms. It's being pulled at an angle of 30 degrees to the horizontal by a force F, applied force F, 100 newtons. The first question is, we are required to state Newton's laws of first law of motion in weights. The second question will be required to calculate the magnitude of the horizontal component of the applied force. Thirdly, we'll determine the magnitude of the normal force. And finally, we're going to look at how we can calculate coefficient of kinetic friction. Let's start by answering the first question, stating Newton's first law of motion in weights, which is just bookwork. Newton's first law of motion says an object will remain in its state of rest or motion at constant velocity unless a non-zero resultant force acts on it. Please notice that every definition has got keywords. The underlined words are very key for the law to make sense. So every time we are stating a law or defining something, keywords are very important. In this Newton's first law, an object will remain in its state of rest is a key terms, and then motion at constant velocity, those are keywords, unless it is acted by a non-zero or net force or resultant force. Notice we're talking about non-zero force, not a zero net force, because a zero net force is not going to cause any change. Let's look at the second question. The second question requires us to calculate the magnitude of the horizontal component of the applied force. From grade 11, you did force resolution. The applied force, 100 newtons, has got horizontal component Fs and then a vertical component Fy. In this case, we are required to find only Fx. Using trig ratios, you'll notice that we can use cosine to determine Fx. And therefore Fx is equal to F cos 30, and if you put your values there and use your calculator, you find Fx equals 86.60 newtons, correct to 2 decimal places. The third question says, calculate the magnitude of the normal force. For us to find the normal force, we need to look at the diagram again. The most important diagram is the free body diagram for vertical forces only. So if you draw the diagram for vertical forces, that's the most important diagram that will give you a clue as to how to get the normal force. Remember, sum of upward forces equals sum of downward forces. And from the free body diagram, we get N plus Fy equals Fg, where we can make N subject to get N equals Fg minus Fy, and Fy equals F sine 30. Substituting your values there, you get your normal force equals 440 newtons. Let's look at the last question, which says calculate coefficient of frictional force, coefficient of kinetic friction. Remember, frictional force depends on the normal force. That's why we have Fk equals mu k times N, and therefore we need to calculate the normal force first, and then use that to get Fk. The box moves with constant velocity, which means the net force in the x direction is 0. So Fx minus frictional force must give us 0. And therefore F net equals 0 equals Fx minus F, which means that Fx is equal to the frictional force, which is 86.60 from the previous question 1.3. Now from Fk equals mu k times n, substituting values there, we get 86.60 equals mu k times 440. Solving for mu k, you find your coefficient of kinetic friction mu k equals 0.20, correct, to 2 decimal places. Thank you for watching the video. Until we meet in the next video. Thank you.